In this section, we're going to look at the sum and difference formulas for the sine and cosine functions. Here are those formulas, and these are formulas that you should memorize. But fortunately, there are some patterns here that will help you keep things straight. First of all, notice that the sum and difference formulas for the sine functions are very similar. In fact, the only difference are the signs here and the signs there. And the same is true of the cosine. For the cosine, the only difference are the signs here and the signs here. For the sine functions, it's plus and plus, minus and minus. For the cosine functions, they're flipped. Now, these are actually just two formulas written out in separate ways. So you actually only need to remember this one and this one, because you can derive the other formulas by using the negative angle formulas. So I'll show you how this works. So let's look at sine of alpha minus beta. We could rewrite subtraction as addition of the opposite, sine of alpha plus negative beta. Now this is a sum of angles, and so we could use the top line. So sine of alpha, cosine of negative beta plus cosine of alpha sine of negative beta. Right, so all we did is instead of writing beta, we have plus negative beta, so we put the negative beta in those positions. From here, we use the negative angle identities. Remember, cosine is an even function, so cosine of negative beta is just cosine of beta. So this is sine alpha cosine beta. And here, the sine function is an odd function, so sine of negative beta is negative sine beta, and we can pull that as negative sine out front. And that gives us exactly what we have up here. So really, these formulas are just two formulas. Now, there are derivations of these formulas, and you can go look them up online if you want to. We're not going to be so focused on it. They're just geometry problems, basically, and you should be able to follow them. But for this class, we're just going to focus on applications more so than derivations. Here are a couple examples. Determine the value of sine of pi over 8 cosine of 5 pi over 24 plus cosine of pi over 8 sine of 5 pi over 24. Now, immediately, what comes to mind is grab a calculator and plug it in. And that's not the goal of these problems. The goal of these problems is to help you practice recognizing these formulas. Now, I've written down the sine and cosine formulas down here for just the sums, and of course for the differences, you just flip the signs of everything. And so our challenge here is to figure out which one of these matches up with the problem. And so if you take a look at it, we have a sine and cosine being mixed together plus cosine and sine. That's going to be this one. And so I'm going to write down that formula underneath it. Sine of alpha cosine of beta plus cosine of alpha sine of beta. And the idea is that by staring at these formulas, you can recognize what alpha is and what beta is, and then apply this formula. So in this case, if we do the comparison, we can see the alpha terms are pi over 8, and the beta terms are 5 pi over 24. So I'll write that over here. Alpha is equal to pi over 8. Beta is equal to 5 pi over 24. Now, this is nothing more than pattern recognition. Once you know what patterns you're looking at and trying to match up with, it's just a matter of finding the right match. Once we have this, we know that this is equal to sine of alpha plus beta. But since we know alpha and we know beta, we know that this is equal to sine of pi over 8 plus 5 pi over 24. And now we just do the fraction arithmetic. Common denominator of 24, so 3 pi over 24. 3 plus 5 is 8, so this is equal to sine of 8 pi over 24, which is the same as sine of pi over 3. And if you remember your values from the unit circle diagram, we know that this is actually equal to the square root of 3 over 2. And this is a little bit surprising that this whole mess comes down to something that we're actually familiar with, but that's just because of how these formulas work out. By simplifying, by making the substitution and recognizing the patterns, we can actually determine what that value is representing. The second problem is similar, except this time we're asked to find the value of cosine of 15 degrees. Notice we're working in degrees at this point, and we're not given exactly how to do this. Now again, you might just grab a calculator and plug it in and give me a decimal approximation, but this says determine the exact value of it, so that's not going to work. What can we do? Well, we need to figure out how to make 15 degrees a sum or difference of angles that we know, right? So we have the 30-degree angle, we've got 45 degrees, we've got 60 degrees, we've got 90 degrees. We also have 0 degrees up here. And we need to find some sort of combination that works. And there are multiple choices here. And it doesn't matter which one you use, because as long as you do the calculation correctly, it will all come out the same. So you might do 45 minus 30, you might do 60 minus 45. No other combinations in this list of numbers will work, but that's okay. Let's do this as cosine of 15 degrees is equal to cosine of 45 degrees minus 30 degrees. Right. Cosine of a sum of angles formula, we actually have the difference here, so we're just going to swap the signs. So this is going to be cosine of 45 degrees times cosine of 30 degrees. Instead of a minus, we turn that into a plus, plus sine of 45 degrees sine of 30 degrees. Go back to our unit circle diagram. What are the values here? Cosine of 45 degrees is root 2 over 2. Cosine of 30 degrees. Cosine is the x-coordinate. It's a 30 degree angle, which is a smaller one, so it's going to be the bigger value. Root 3 over 2. Plus sine of 45 is root 2 over 2. Sine of 30 degrees is going to be 1/2. And so when we plug it all in, root 2 times root 3 is root 6. So we have root 6 over 4 plus root 2 over 4, which we can put under a single fraction, root 6 plus root 2 over 4. There are other manipulations you can do to try to simplify that further, but it doesn't actually take you anywhere. So that's how we determine the exact value of cosine 15 degrees. It's interesting because up to this point, we have not had exact expressions for angles other than the 30, 60, 90, and the unit circle diagram values. But what this is showing us is that we have some tools now that allow us to get a few more values out of a few more exact values for the sine and cosine functions.